So here's 30 farmers and a bunch of data given. Instead of taking too much time for you to calculate the frequencies, because that's just counting, I'll give you those values. But then I'll get you to fill out the rest of the chart and then figure out the mean and standard deviation by hand. Multiply them all out. Did you add up to 150? That's a way to check to see if you got one wrong, or maybe more. The differences are easy. Squaring them is easy, and when you add them all up times by the frequency, you get 152. So if we wanted to, with this data, if we wanted to calculate our mean, which you had to do before you figured this out, right? You had 150 divided by 30 gives us 5, and you needed that before you could fill out column number 3. And then, once you've got all this data, this 152 divided by 30 gives us our variance at 5.06 and our sigma at 2.25. Now we're going to learn later when we do probability and then combine probability and statistics that once you find out what your mean is, so we know that our mean is 5, and your standard deviation, in this case, is 2.25. You're going to be able to really get a sense of what that data is. Because if you go one standard deviation up and one standard deviation down from your mean, so that would be going up to 7 and down to 3, it would say that about 68% of your data will be between 3 and 7. And if you go 2 standard deviations up, so that would go up to 9.5 and down to 0.5, that would already be 98% of your data. So your standard deviation tells you where things are at. You give those 2 numbers and you can expect that majority of people will be between, or majority of data will be between 0 and 9.5 for this one. If we look at our data, sure enough, all of our data, 100% is. And we'll look at how that standard deviation can tell us more information about things. And when we do probability and stats, we can figure out some pretty cool stuff later on that involves this. So what we know, if you have a low standard deviation, because almost all of your data is within 3 standard deviations is the general rule, a low standard deviation means that all of your data is grouped together really tightly. So in our first example, when we looked at test 1 and test 2 would have a smaller standard deviation because that data was all closer than test 1, which was more spread out. So higher standard deviations show the data is more spread out. Some properties of standard deviation: it's never going to be negative because you're always squaring. So we've seen why that would happen. It is sensitive to outliers. So if in that last example where you went from 0 to 9, if all of a sudden you would add 100 in there, okay, that's going to be very far away from your mean. And when you square it, so the mean was 5. If 100 was in there, that's 95 away. And when you square that, you're going to get a huge number. So outliers can really, really affect the mean. So with data with approximately the same mean, the greater the spread, the greater the standard deviation, which makes sense. The farther it's spread out, the more that you'll have here for your standard deviation. If all the values are the same, there is no deviation. And the mean would be that value, and you'd have all zeros for the difference. And then when you square all those zeros, you would get 0. So then the standard deviation would be 0. This sometimes comes up on final exams as a way to see, do you understand how things affect the standard deviation? So if you were to add the same number to every value in the data set, so think about the last one that we did from 0 to 9. If every value that we had, you added 3 to it, that's going to just shift everything over 3. That's going to shift your average over by 3. So your average will stay, the 3, but your spread of your data is still going to be spread out the same way. So your standard deviation wouldn't change. So there might be a small little question on an exam that says, what would happen if I added 7 to all this data? Calculate the new mean, calculate the new standard deviation. And having this understanding, and that's why we did it by hand, so you could really see what's happening, you'd be able to answer that question quickly. But if you multiply or divide each number by a certain amount, the mean and the standard deviation will both be multiplied or divided by that value as well. Now that we've done some by hand, if we go back to the very beginning, when we had our, oops, too far, here we go. When we go back to this statement, maybe this statement that sounded really strange when I said it the first time, maybe it makes sense now that we've done it by hand. The variance is the arithmetic mean. Arithmetic mean is when you divide by how many you have, of the squared differences. So that's when we subtracted the mean from our score and squared it, of each value and the mean value. So now that statement, now that you've done it by hand, when you read it, maybe it makes a little bit more sense.